You can reflect a figure to construct a congruent figure. So we will reflect rectangle FGHJ over the line to form a congruent rectangle. So the first step is to reflect points G and H over the line. So G and H are each 1 unit to the left of the line. So we will plot points G prime and H prime so each is 1 unit to the right of the line. So G prime would be right here. H prime right there. Points F and J are each 4 units to the left of the line. So we will plot F prime and J prime so each is 4 units to the right of the line. F prime, J prime. We can connect these points to form a rectangle, and because rectangle F prime, G prime, H prime, J prime is a reflection of FGHJ, the figures are congruent. If a segment is parallel to the line of reflection, what do you know about the image of the segment? Well, it will also be parallel to the line of reflection. So let's take a look at the next practice problems here. Describe the line of reflection in words to show that the two figures are congruent. Then draw the line of reflection. So again, we have a fairly difficult to see quadrilateral here. So we will draw this back in. Now go ahead and do that for our second example as well. Okay. So I'm not quite as worried about you being able to describe this in words as I am you being able to put in the line of reflection. So we should be able to, at this point, visually determine the location of the line of reflection for each of these examples. Reflect quadrilateral ABCD across the dashed line to form quadrilateral A prime, B prime, C prime, D prime. Note that A and D are both 5 units to the left of our line, so we will move them so that they are 5 units to the right of our line. So this will be A prime. Here we will have D prime. B is 3 units to the left, so we will move it 3 units to the right. C is 1 unit to the left, so C prime will be 1 unit to the right, connecting each of the points to make our segment. Similarly, with our second example here, A is 3 units above, so A prime will be 3 units below. B is 3 units above. B prime will be 3 units below. C is 2 units above. So C prime will be 2 units below. And D is 2 units above. D prime will be 2 units below. We then connect our vertices to make a quadrilateral. You can reflect figures on a coordinate plane and identify the coordinates of the vertices of the image. So for this we have a few steps. So plot 1 would be to plot the image of the figure reflected across one axis. So we could either reflect across the x-axis or the y-axis. Find the coordinates of the vertices of the image. Compare the coordinates of the figure and its image to find a rule for the reflection over the x-axis. So if we look at the coordinates, notice how our x is always the same value because we're not moving left or right. We're reflecting over that x-axis. So here's your x-axis. And that's what we're reflecting over. So our x value of our point stays the same, but our y value changes. So our rule here is xy goes to x negative y. We can then plot the image of the figure reflected across the other axis. So we can reflect triangle KLM across the y-axis to form triangle K double prime, L double prime, M double prime. So now our line of reflection is the y-axis. So now instead of our x value staying the same and our y value changing, our y value stays the same and our x value changes. So a good rule here is that the value that changes its sign is opposite of whatever axis that we are reflecting about. A point is plotted at the origin. What are the coordinates of its image if the point is reflected over the x-axis or the y-axis? How do you know? Well, think about this. The origin is where the x-axis and the y-axis meet. The coordinates are 0, 0. So if we reflect that, it's still going to be 0, 0. So in review, we can reflect line segments and angles across a line. We can reflect a figure across a line to form a congruent figure. So we can now apply what we know about reflecting figures to graph congruent images on the coordinate plane. So in our last set of notes here, we can reflect triangle FGH across a y-axis by plotting the images of the vertices. Then we can determine their coordinates. So since G is 1 unit to the left of the y-axis, we will simply move G to 1 unit to the right of the y-axis. Then we would do the same things for F and H as well, so that we found triangle F prime, G prime, H prime. And note that as it says up in the top corner here, corresponding vertices are the same distance from the y-axis, because that's what we're reflecting over. We can use reflections to show two triangles are congruent. So we can describe the sequence of reflections to show that triangle ABC is congruent to triangle TUV. And let's go ahead and put TUV back in here. So we will now show that ABC is congruent to TUV. So first we find the coordinates of reflection of A, B, and C over the y-axis. So since A is at 1, 2, B is at 1, 5, and C is at 5, 2, we can follow our rule. Since we are reflecting over the y-axis, we change the value or the sign of our x value. So we will have points at -1, 2, -1, 5, and -5, 2. Then we can reflect that about the x-axis. So since the coordinates of A double prime, B double prime, C double prime are the same coordinates of TUV, and it's a reflection followed by another reflection, then we have that A double prime, B double prime, C double prime is congruent to TUV, which then makes ABC congruent to TUV. So, can figures on a coordinate plane be reflected over lines other than the x-axis and the y-axis? The answer here is yes. They absolutely can be. So we would just have whatever graph that is, whatever line that is, and we would just determine how many points or units away each of our points is from that line. So we can, in fact, reflect over lines that are not the x or y axis.